Okay, so you want to calculate mass, moles, and molar mass of a substance. Well, let's first start off by defining the terms. Well, mass is the matter or the amount of matter in a substance. And moles is a measurement for the amount of substance. So it is a measurement for, for the amount of substance. And molar mass is a combination of both these. It is it is basically the mass of a substance in 1 mole. So it's mass of substance in 1 mole. Okay, so if you don't know where to find your molar mass, then you can look at your periodic table, and under each element symbol, you'll see a number, and that number is your molar mass. For beryllium, the molar mass is approximately 9 grams per mole. So with that out of the way, let's calculate the mass, moles, and molar mass of a substance. What the basic premise is, if you want to calculate something like moles, you need to have mass and molar mass. So what that means is, if you want to calculate one of them, you need to have the two other ones. So for example, let's say I want to calculate the moles. Well, I need the mass and the molar mass. And this can be written out to moles equals mass in grams over molar mass in grams per mole. Make sure your mass is in grams for a successful conversion. So this technique can be used for any of the three. And one thing I would like to point out is the lines on the triangle indicate if you want to divide or multiply. So if I want to calculate something like moles, then the horizontal line tells me that I need to divide mass over molar mass. If I want to calculate something like mass, the vertical lines on the triangle tell me that molar mass and moles have to be multiplied. Okay, so now with all this information, let's try to solve a question. Consider the following equation. 2NH3 plus 3CuO will give you N2 plus 3H2O plus 3Cu. If 2.56 grams of ammonia is reacted with excess copper oxide, calculate the mass of copper produced. So the significant molecules that are mentioned in this question are ammonia, copper oxide, and copper. And since copper oxide is in excess, that means ammonia will be the limiting reagent. And with the limiting reagent, we can easily identify how much of a product is formed. Okay, so the first thing we want to do is look at the information given in the equation. It says 2.56 grams of ammonia is reacted. What we can do with this information is figure out the moles of ammonia formed. And we're already given the mass. So 2.56 is the mass, and it's already in grams, so we don't have to convert it. The way you can calculate the molar mass of ammonia is by looking at the individual atoms in ammonia and looking at their molar masses. So nitrogen has a molar mass of 14.01 and hydrogen has a molar mass of 1.01. And since there are 3 hydrogens, that means we multiply this molar mass of hydrogen into 3. And this will give us 17.04. And that is the molar mass of ammonia. Make sure not to multiply the molar mass of NH3 into 2 just because there's a 2 in front of NH3. That would be incorrect. Okay, so now we can calculate the moles of ammonia, which would be 2.56 grams over 17.04 grams per mole, which would give us approximately 0.15 moles. And that is the moles of ammonia. And with this, we can calculate the moles of copper. So we see that there are 2 moles of NH3 and 3 moles of copper produced. So that means that for every 2 moles of ammonia reacted, 3 moles of copper are formed. So that means the ratio is 2 to 3. And this basically means that if there is 0.15 moles of ammonia reacted, then 0.225 moles of copper are formed. The way I calculated 0.225 is by doing 0.15 divided by 2 into 3. Okay, so now the second step. We found the moles of copper produced, and now we just need to calculate the mass. Okay, so going back to the triangle, we want to find the mass. So we have the moles already, which is 0.225. And now we need to find the molar mass, which can be given in the periodic table. The molar mass of copper is 63.55 grams per mole. And now if you multiply both these terms, you should be given the mass of copper produced. And once we multiplied it, we get the answer to be 14.3 grams.